Hello, can you hear me? Can
Yes, sir. Good evening, sir.
Good evening. Hello. We will wait for another 3-4 minutes and we'll start the session because there are very less number of people as of now. Is it okay? You can message me in the chat box if you want to reply. I hope you can hear me.
Sir, is it a geotechnical engineering subject today?
Yes, yes, it is geotechnical. So I hope you can see the slide. So if someone of you reply, I can start the session because it's already 5 minutes. I waited for 5 minutes. You can see the slide? Okay, okay. Okay, you can mute yourself. Let me check how many. Yeah. In the last class, we have already discussed about the Poisonous theory. So we have discussed about the assumptions as well as what is the advantage of this theory and formulas and all. So before here we'll read the question first, then we will go through the other topics in meanwhile. Anyway, so a concentrically loaded isolated square footing of size 2 meter by 2 meter carries a concentrated vertical load of 1000 kilonewton. So considering Bouguereau's theory of stress distribution, the maximum depth in meters of the pressure bulb corresponding to 10% of the vertical load intensity will be how much? So here what is the new word which we have come across? Anyway, we have discussed what is the use of this Bouguereau's theory. Here the new word which we have come across today is pressure bulb. Okay, so first we will know about the pressure bulb today. See, whenever there is a load on the ground surface, so this is the ground level, you can say. So whenever there is a load or any pressure, you can say aerial load, there will be increment in the stress in the ground. See, there is already in situ stress at this point. Let us say what is the in situ stress, which we have discussed already. Let us say this is H and unit weight is gamma. Gamma into H is the in situ stress. When there is a Q, this Q will increase the pressure in the ground. So that increment in the pressure is denoted by delta sigma. Okay, so that will be different at different depths and different in the horizontal space also. If you go, this is horizontal space and this is vertical space. Okay, if you go any direction, the delta sigma will change, and at some points that may be same. So let us take this. So due to this Q which is applied on the ground level, so I am taking a particular area, okay, or a particular volume of the soil below the ground level, in which the intensity in the increase of the stress will be reasonable. So beyond which, suppose if you go beyond this area, okay, the increment in the stress is not significant, you can neglect that. Okay, this is in the shape of bulb and this is containing the incremental stress due to this Q. That is the reason why this is called the area which is subjected to the incremental in stress due to this applied load, that is called pressure bulb. Okay, so now the if you see that, I'll explain another thing here. So if you talk about the increment in the stress, let us say here at this point delta sigma equal to 10, okay, 10 kPa. At some point other than this point, at some point it delta sigma may be 10 and it will be 10. That point may be here, okay, delta sigma here also 10 kPa. Like that there are some number of points. Okay, you are seeing only 2D diagrams here, that is the reason why you can see only a circle or ellipse here. So but in the 3D ellipsoid or the 3D bulb shape, you can see that bulb shaped surface. So here if you connect all the points which are having the same incremental in stress due to this Q, that will form a shape of bulb. Okay, that will form a shape of bulb. So as this is having on this surface, this is a 3D surface. Okay, on this 3D surface, if you take any point, that point is showing the incremental in stress which is same at every point. That is the reason why this is called as isochrone, I think. Let me correct this. I'll correct in the next class, maybe isochrone or isobar. Mostly isobar it is, because same pressure you can call it as isobar. So here this is all about the pressure bulb. Pressure bulb is a surface which is locus of the points the points which are referring to the same incremental stress below the ground level. That is what the pressure bulb. And now so as this seeing this surface, suppose this is also pressure bulb which is showing same incremental in stress everywhere on the surface. This is the maximum depth below the ground level where suppose I'll give you P1, P2, P3, P4, P5. Let us say this is P5, so P6, like that, P7 at Pn. So which point will be deeper compared to all other points? Here all points are having same incremental in stress delta sigma, all points P1, P2 up to Pn. Okay, all are having same incremental in stress, but which point will be deeper? That point, the point which is exactly below the line of application of the load, that will be the deeper compared to the other points. So now here the question is, a concentrically loaded isolated square footing of size, let us draw that. Okay, so that is said that, okay, this is ground level and there is a 2 by 2 meter footing. Okay, I am not drawing this side anyway. 2 by carries a concentrated vertical load of 1000 kilonewton. Okay, it is carrying 1000 kilonewton, right? The maximum depth, considering this theory, the maximum depth of the pressure bulb, see, maximum depth of the pressure bulb will be always exactly below the line of application of the load. Okay, that is the maximum depth of the pressure bulb, any pressure bulb you take. Okay, corresponding to 10% of the vertical load intensity. Here, what is the intensity of the application of the load? Intensity of the applied load. Okay, applied load. See, here it is given in terms of concentrated load. If you convert into intensity, that is nothing but pressure, 1000 divided by 2 by 2. We are just converting it into pressure. Okay, you can say sigma, which is at the ground level, How much? 1000 by 4, 250 kilonewton per meter square. That is the sigma at the ground level. Okay, now what is asked? At some point, at some depth, okay, at one depth, the intensity, the delta sigma will be 10% of the vertical load intensity. So if you take the 10% of this intensity, at some point it will be, at one point it will be like, let us say pressure bulb in this, because it is aerial load, so like this. At one point this will become, this is 10%, that means 0.1 times q. What is that depth? It is asked. Okay, what is this z? So what do we know? The increment, this is all increment in stress. We know the formula delta sigma according to the Bosnius theory, 3 by 2 pi into 1 by 1 plus into q by z square, right? This is the formula for increment in stress at any depth. Okay, now as anyway the maximum depth corresponding to increment in stress, that is exactly below the line of application of the load. So this R term will be 0, as we have already discussed in the previous classes. If it is 0, then this total will become 1. Then delta sigma will become 3q by 2 pi z square, right? So here q we know, and delta sigma, what is the delta sigma at this depth? At that z. So that is the 10% of the vertical load intensity. So how can we write here? So delta sigma equal to 3q by 2 pi z square. Delta sigma is 10% of the vertical load intensity, and the load is 1000. Okay, what is q? Q is 250 2 into pi z square. Can someone of you calculate using calci and tell me what is z square and z. You can give me the value of z. So I'll wait for 30 seconds and I hope somebody is calculating. Can I expect the answer from any audience? Shall I do this? Sorry, this is 250. Sorry, this is 250. Then it becomes, this will go this 25, 40s, 220.
0.228.
How much?
Z is 0.228, sir. Z square is 0.052.
Give me only the value of z.
0.228, sir.
228.
Yes, sir.
Is it the answer? Let me check. Exactly, answer is 4.36.
Already I have given in common box.
Acha, acha, okay. Anyway, so z is,
4.3.
so it's not 0.228, it's 4.36 meters. Okay. See, whenever you calculate these numerical questions in the GATE exam, you try to take all the decimal points while calculation, during the calculation part. Suppose somewhere you are getting some 20.999967, you take all the decimals, like 4-5 decimals. At the end, you can convert. Suppose they have asked round off to 2 decimal places. You can convert that at the end, because if you are always converting during the calculations, what may happen, it may go up to 4.75 or 4.45, which may not be in the range of the answer which is given in the key paper. So that is the reason why you always take all the decimal point, maybe 4 or 5. 4 is enough, as you have already, maybe calci is allowed or not, I don't know. Maybe if it is not allowed also, there will be virtual calci. You try to take at least 4 so that you will get the proper answer. Anyway, so this is the answer. Is there any doubt? Z equal to 4.36 meters below the ground level. If there is no doubt, I'll move to another question. I hope the questions related to the Bouguereau's theory, I think you can solve, because we have solved another question also in the previous class. So I'll be moving to another question. So can you see the question? Another question which is of which is from the set 1. Can someone of you reply?
Yes, sir. You'll see.
Yeah, right. Okay, let us go through the question first, then we will discuss what are all the things which we come across in this newly. A raft foundation of 30 meter by 25 meter is proposed to be constructed at a depth of 8 meter in a sand layer. Okay, see, that is anyway in the bold letters, no need to underline. A 25 meter thick saturated clay layer exists 2 meter below the base of the raft foundation. Let me check, somebody is joining or is everyone allowed? Yeah, fine, nice. Yeah, anyway, I hope you can see the slide again. there is a 25-meter thick saturated clay layer which is existing 2 meters below the base of the raft foundation. So below the clay layer, a dense sand layer exists at the site. Now a 25 millimeter thick undisturbed sample was collected from the mid depth of the clay layer and tested in a laboratory odometer under double drainage condition. It was found that the sample had undergone 50% of the consolidation settlement in 10 minutes. The time required for 25% of the consolidation settlement of the raft foundation will be how much? So the question is, just let me take 2 seconds. Yeah, the question is about the raft foundation. What is raft foundation? See, I don't know whether you have come across these foundation footing terms in your lectures. Most of you have already completed your bachelor's, so you must have known that, but some of you may not be knowing. But foundation, footing, these are the words which we generally hear in our regular life. So foundation is nothing but a footing or foundation, nothing but which will transfer the superstructure load. Take ground level. So there is a building, suppose there is a building. So building has the columns, okay, there are some columns. Each column is supported by a footing inside the soil, okay. These are called footings. See, if you take multi-story building and which are having high floor areas, there will be many columns, okay. So each column has footing, as we discussed, each column has footing, okay. Now what happens, now if you see the floor area, the top view of this floor area, there are footings like this, okay. This I am talking about these footings. If you see from the top, okay, like this, there is a column. See, as a civil engineer, you must be knowing what is top view, elevation, all those things, because you have studied already in your first year engineering drawing. So if you see any cuboid or cube, this is the footing, okay, this is the footing. If you see from the top, you can see this, okay. If there is a column of shape, cuboid shape, okay, that will be there in the at the center or at any point. For the time being, we'll take at the center. So this is column, this is the footing, this is column, and this is the footing, anyway, right. So these are all the footings for a particular building. So now what I'll do, so I'll draw a outer line for this, okay. If the total area is, let us say, A, and area of footing, sum of the areas of footing, let us take this as F1, sorry, A1, A2, like that, A3, A4, A5, A6. Now A1 plus A2 plus A3, all the areas of footing, if you sum up, if it is greater than or equal to total area, that whichever is covered, suppose this is the total area of the plan where some footings are there, okay, like this, this is the total area, and these are all A1, A2, A3, then AN, okay. So if it is, sorry, this is 0.5 into A, it is not just A. If sum of all the areas of all the footings, if it is crossing, if it is greater than 50% of the total area, then what do? We will go for a common footing for all the columns. The common footing will be like this, okay. You can search in the YouTube after this class, Raft Foundation, you can say raft footing or raft foundation, okay. I'll write Raft Foundation. Raft Foundation is a common foundation for all the columns. Okay, this is the foundation. Let us say there will be columns like this. Okay, there will not be individual footings. This common footing is called as Raft Foundation, which has lot of width and which has greater width and greater length compared to small footings. Okay, individual footings you can say. Now this is all about the Raft Foundation. That is the reason why if you see this 30 meter by 25 meter, it's the area of the land or the sides of the land, the floor, it is very big. So that much big foundation, that is the reason why it is Raft Foundation, right? Now it is proposed to be constructed at a depth of 8 meter, at a depth of 8 meter in a sand layer. Okay, so let us draw that first. So I'll draw in the new slide. So this is ground level. They are saying that at a depth of 8 meter. At a depth of 8 meter, foundation is constructed. Okay. So you need to know that another term called depth of foundation. So depth of foundation is the distance between the ground level and the bottom of the footing. Okay, this is called depth of footing. This 8 meter from the ground level to the depth, and this is the footing. Okay, so this is the transition part between the column which is above the ground level, connecting part between the column and the footing. This part, some part will be like that. Now the width of the foundation, the height of the foundation may not be equal to the depth of the foundation. This may be another thing. It may be like you can say h. Okay, anyway, so go back to the question. So it is at a depth of 8 meter. Another thing is that a 25 meter thick saturated clay layer exists 2 meter below the base of the foundation. So the thickness of the saturated clay layer is 25 meter, and it is existing and it is starting 2 meter below the base of the foundation. So if it is the base of the foundation, below that, let us take 2 meters again. From this point, clay layer is starting. Okay, this is the clay. And what is the clay layer thickness? And that is said 25 meter. Now what is the total depth of the sand? This is the sand layer. It is mentioned that it is a sand layer. This is sand layer, and this is clay layer, which is of 25 meter depth. And below that, what is mentioned? Below the clay layer, a dense sand layer exists at the site. So that means after 25 meter of clay layer, again there will be another, this is dense sand. Okay, this is all about the site conditions. Now let us read the question. What is said? A 25 millimeter thick undisturbed sample was collected from the mid depth of the clay layer and tested in a laboratory odometer test. Odometer test is nothing but consolidation test. You will get all the consolidation parameters from this odometer test. So I'll tell you what is double drainage condition, what is odometer, what are all the things. Anyway, what we have to concentrate on in this question, that 25 mm thick, a sample, a small sample, which is taken from the mid depth of the clay layer, and it is tested in the laboratory under the double drainage condition. We'll talk about these things. After testing, it was found that the soil sample had undergone 50% of the consolidation settlement in 10 minutes. We will note down that given data. Okay, what is the given data? Sample is tested in lab. Okay, what is the thickness of the sample? This is a small sample. Okay, that thickness of the small sample is 25 mm. Just see this. Oh, something is deleted. Yeah, see, there is a dense sand. See, compared to 25 meters, 25 mm is just negligible. Somewhere at the midpoint, mid depth, it will be just a point kind. Okay, it is nothing but a point compared to the 25 meter. From that point, they have taken some sample, then that is tested in odometer test. Okay, under double drainage condition. Double drainage. And what is the other thing? So after, what is that odometer test? I have told you that is consolidation test. So consolidation test, they are actually compressing the soil under some load. So when they are compressing the soil, the consolidation for any particular soil element or soil condition for a particular load, suppose you are applying 100 kilonewton on a sample. Okay, let us say this is 100 mm. Okay, you are giving this much load. These are random numbers, don't think that these are existing in the real field condition. When you are applying 1000 kilonewton, this gets compressed, it will become 90, then slowly 80. At one point, maybe after becoming 70, it might stop. After that, this load will not decrease the height or volume of the soil sample. Let us say height, the settlement. Now what is the settlement? 30 mm, because it has reached, the height has reached 70. This final settlement is called primary settlement of the soil sample. Okay, now even if you keep that 100 for some more days or years, the settlement will not increase. That is 30. The final settlement is 30. Now if you keep that 30 mm as the consolidation settlement, people say that consolidation settlement. Now if somebody is saying 50% of the consolidation is reached or 20% of the consolidation is reached, that means let us say 50%, 15 mm is done and another 50 mm will be happening under this load. Now this 30 mm is not for this soil condition, not just for this soil condition. This 30 mm is that for that particular soil condition as well as for that particular load. If you keep this constant, this value will be constant. So for the 100, this soil will give only maximum 30. Consolidation settlement will be 30. If you increase this 1000, the value may be 50. After reaching 50, it might not increase. So for a particular load, there will be particular consolidation settlement that is constant for particular load. So anyway, here what are all the things which are given? Load is not given anyway. We have been given time for the 50% of the consolidation settlement. We have been given that time in the laboratory. And now what should we find out? The time in days required for 25% of the consolidation settlement of the Raft Foundation will be how much? So here they are asking 25% of the consolidation settlement of the Raft Foundation. That means they are talking about the field condition now. They have given the data of the laboratory and they are asking us to find out the consolidation settlement in the real field. Okay, let us write. Yeah. So this is the given data. Now, given data is still, there is something left, that in time 10 minutes they have observed 50% of the consolidation. 50% of the consolidation settlement in lab of thickness 25 mm, of double drainage. These are all important, right? That is the reason why I am writing again. Now what is the question? Question is 25% of the consolidation for this, how much time in the field? Okay, in the field, what is the height of the clay? 25 meter, whereas here 25 mm, and here 50%, here 25%, here 10 minutes. We don't know what is the time, we have to find out in days. Okay, now here double drainage in the field also, it is double drainage or not, we will see. So I'll explain first. Okay, there is some problem just like that we have seen in the last class. Let me check this, give me 1 minute. Okay, okay, now there is a Terjagis theory. Terjagis one-dimensional consolidation. One-dimensional consolidation, which we have to know first, that one-dimensional, this is just an assumption based on which there are some formulas which are developed. Taking soil and applying some load on it, if water. So what is the consolidation? Consolidation is the settlement of the soil due to expulsion of the water from the soil. Okay, water is coming out due to the application of load, thereby the settlement is happening. So if the expulsion of the water is happening only in one direction, that is only vertical direction, that is called one-dimensional consolidation. Generally what happens in the field, water can move any direction when load is applied. Okay, so that is three-dimensional consolidation. But for the time being, according to the theory, that is Terjagis one-dimensional theory, one-dimensional consolidation. Let us take a box. Okay, now there is a clay layer. Okay, and this is, let us say, sand, and there is some load which is applied. See what happens when there is a load, this total soil will get compressed. See, remember, clay takes time for the consolidation, whereas sand doesn't take much time to get consolidated, because sand has more permeability and it will expel the water out within very less time. You can say within hours, within some hours it gets consolidated. So that is the reason why we don't talk about the consolidation generally in the sand, whereas clay takes years. It may take 5 years, 3 years, even 10 years to consolidate to the final settlement, because clay has very less permeability compared to sand, because its void ratio is less compared to the sand. That is the reason why we talk about the consolidation for the clay layers, not the sand layers. So there is a load here. Now clay layer is getting compressed, right? Due to what? Expulsion of the water, right? From the clay layer to the sand layer. Anyway, whatever is the water which is in the sand layer, that will get expelled out very easily, Now what is there from the clay layer to the sand, that is what which is important right now. So now if you see, as sand is there both sides of the clay, above and below, the water can move both directions, right? Suppose in another condition, let us take, there is a clay layer, okay, and there is some rock which is impermeable, okay, this is clay, and there is a sand, okay, and there is some load. What happens when there is a load? Here water from the clay layer should go up, it cannot enter into the rock, right? This is impervious. So based on this two conditions, we can say whether it is double drainage or single drainage. Now see here, drainage is happening on both directions. This is called double drainage, okay, double drainage condition. Whereas here only it's in one direction, that two upward, it is happening, the expulsion of the water is happening only in top direction. That is the reason why it is single drainage, okay. This is the difference between double drainage and single drainage. Whereas in the laboratory they conducted with that small sample, they conducted with double drainage. There are two drainage for this soil sample, okay. That is the reason why they have say some porous stones, they will use porous stones where water can be expelled out from the both directions. Anyway, now coming to the path, the traveling path of the water particle. See here, the maximum traveling path for a water particle in the clay layer is half only, because the water particle here will go out like this, water particle will go from this, it will not take this path obviously, because it is more length. So in the double drainage condition, the maximum path traveled by a water particle is half of the clay layer. Suppose this is total height is h, the drainage path, okay, drainage path will be h by 2. D generally we denote it by D equal to h by 2 in double drainage. Whereas coming to single drainage condition, what is the drainage path here? If this is h, the clay layer height is h, can someone reply from the audience?
H only, sir.
H only. Why?
It's a single drainage.
It's a single drainage. A particle, move
in one direction.
So the water particle which is at the bottom also has to travel to the top to come out. So it has to travel h distance. The drainage path will be equal to h in the single drainage. That is the reason why. So it will be D equal to h by 2 and h in double drainage and single drainage respectively. That's how we divide. Now we understood what is drainage path, and we have understood what is the consolidation process and what is 1D consolidation. Now we'll move to see, there is we have already talked about excess pore water pressure. Excess pore water pressure. When does it occur in a soil? When there is a load. Suppose now again there is a clay and sand below and above. This is clay. Now what do I do at this point? No, at these levels, okay. When there is a load, the water inside the clay, the water inside the clay will take the load whichever you apply here, okay, first. Then what happens slowly, the water will transfer that load, the applied load, to the soil, to the clay particles. The initial part, when you apply Q, what is the water pressure? The excess pore water pressure, that is also Q. Let us say this distance is Q, this width is Q. Overall depth from here to here, overall depth will be subjected to the same pressure. This is the water pressure, by the way. This is U excess pore water pressure. Excess pore water pressure will be equal to Q, which is applied. Okay, at the initial point at time equal to 0. So as the time progresses, what happens? Slowly the water which is nearer to the sand layer, nearer to the pervious material, that will go out. Then what happens? The pressure which is taken by these soil particles, that is transferred to the soil particles. The pressure which is taken by the water particles nearer to this, that will be transferred to the soil particles. That means this Q will be reduced, means U excess at time equal to T1, let us say U excess at this point. Now at this bottom and top, that will be lesser than the middle, because this water still is, it is still in the middle. For this water to be traveling to be outside, then it will take time. That is the reason why it's still carrying this pressure. So at one particular point, you can say, you can draw this diagram, U excess diagram. It may be like this. It may be like this, because the pressure taken by this water is reduced from the Q to some value which is less than Q, whereas in the middle the water pressure is still existing. Like that, at one point it will be like this. At some, if you still give the time, what happens? This water also will go out. At the end, it will decrease slowly. Then at the end, it will become excess pore water pressure become 0. Okay. So at every depth, see, this is Z, and this is UI diagram. Okay. Pressure, pore pressure, excess pore water pressure. So considering all these things, the phenomena, the depth and the excess pore water pressure at different times T, considering all these things, there is a equation which is developed. You can follow any standard book, as I told you, book by Gopal Ranjan or book by Arora. You can follow them. You will be getting the total derivation. That derivation I cannot explain in the class, but final differential equation I can write for you. That is partial differentiation of the velocity double derivation of the excess pore water pressure to the with respect to depth. So this is the differential equation which is derived from this concept. Then the solution of the differential equation at the end, here after this it can be converted into let me take some let me go through something. Yeah, this is not the, this is one of the differential equations which will come in between the derivation. So at the end we will be getting, whereas this V is velocity, K is permeability, gamma W is unit weight of the water, whereas this is pore water pressure, Z is the depth. Now this is a partial differential equation which comes in the derivation, in between the derivation. At the end we will be getting CV into partial differentiation of the pore pressure. This is U bar, you remember this is time, with respect to time. This is the final differential equation which you are getting, where CV is called coefficient of consolidation. Coefficient of consolidation. Okay. Now this CV formula is, I mean, during the derivation only few terms taken in terms of CV. This is K by gamma W into MV. During the derivation you will be having some more terms. Taking all those terms, they have given this term. They are replacing those terms with CV. That's it. So this is called coefficient of consolidation. K is permeability, gamma W is unit weight of the water, whereas MV is coefficient of volume compressibility of the soil. Okay. MV is coefficient of volume compressibility of the soil. Okay. Now this is analogous to the inverse of the bulk modulus. So what is bulk modulus? Which is generally denoted by K, stress by volumetric strain, right? You can say delta sigma by epsilon E, whereas epsilon E you can write delta V by V, right? This is the bulk modulus, whereas this is inverse of bulk modulus. It is analogous, it is not equal to inverse of, okay, it is just, but it is negative of. Okay. Sorry, this is not incremental in stress. This is the stress which is there, due to which the change in volume is happening. Now this is how MV equal to, you can write delta V by V sigma. Okay, this is what coefficient of volume compressibility. So now you know the term MV, you know the term CV, which is coefficient of consolidation, K by MV into gamma W, right? What is the other term which we have come across in this? No, nothing. Now here this is the differential equation when you derive this concept. Okay, then the solution of this differential equation, which is star mark, solution of that differential equation will give you new terms. Those are, one of them is new term which is introduced, this is called time factor. Okay, the solution of that differential equation will give you a new factor, that is time factor. This is equal to CVT by D square. Okay, you should remember this formula. See, nobody will be asking you the derivation part in the GATE exam. You need to know the solution formulas, directly the solution which came from the derivation, partial differential equation. So this is what which is important. TV is time factor, whereas T is the time at any time of the consolidation, during the consolidation at any time, and this CV is the coefficient of consolidation. You remember that this is constant for a particular soil during consolidation from 0 to 100% of the consolidation. This does not vary. This is constant for a particular soil under particular load. Any load, you can take any load. Now this D, as we just discussed, D is drainage path. If it is double drainage, it will be half of the thickness of the clay layer or any layer, soil layer. If it is single drainage, D will be equal to the thickness of the clay layer. So now this is the solution. Now how to find out TV? There is another formula for TV from the percentage of the consolidation, that is, so now I am just writing, I am keeping it CVT by D square. Okay, and TV is changing. This term time factor will change from 0 consolidation to 100% consolidation. It is time factor. Time factor means what? From 0 time to the final settlement time. So this, there is a formula for it according to the percentage of the consolidation, pi by 4 u, percentage of the consolidation it is, divided by 100 square. You can apply this formula when percentage of the consolidation is less than 60%. Okay, when it is greater than 60%, when it is greater than 60%, there is another formula which is that also you have to remember in your for your gate exam. So I'll be writing, just for the timing I'll be writing this. This is 1.781 minus 0.933 log base 10 100 minus u in percentage. So this is another formula when percentage of the consolidation is greater than 60%. So now you know two types or two ways to find out TV. If you know CV, time, D, you can find out TV. Then from there you can find out what is the percent of the consolidation. Or if you know the percentage of the consolidation, you can find out TV. From that TV you can find out the time. So this is how you should remember these three formulas, right? So now what is the question? Based on all these things we can solve this question. So here in the laboratory, for the time of consolidation 10 minutes, the percentage of the consolidation is 50, right? This is what given. In this time this much consolidation happen, that to laboratory H is how much? 25 mm. And what is the D then? It is double drainage, remember, double drainage, right? D will be 25 by 2, 12.5 mm. This is, let us say, DL, HL, TL, because laboratory it is. So now from this can we get anything? You know percentage of the consolidation, you can find out TV, right? TVL. What is TVL? Pi by 4. Which formula should I use? I should use this because percentage of the consolidation 50, which is less than 60. So I can use 50 by 100 square. So can somebody tell me exact value of this? Please be quick because we don't have time. I want answer in 10-15 seconds. So you should always be ready with calcs when you are in the class. So I'll be finishing this question within 5 more minutes. Please give me the answer as soon as possible. Yeah, tell me. 0.196. Anything else after that? 3. Okay, I told you to take at least 3-4 because you will get the proper answer. Okay, I am believing you. I am continuing the question. Okay, now I got the TVL for this particular time. Okay, now if you know the TV, you can use this. Let us just check. Can you use that or not? 0.1963 equal to CV. We don't know what is CV. Do we know what is T? T is how much? 10 minutes, right? So shall we convert it into days, because answer is asked in the days, so we can convert it into days. How to convert? Say D square. What is D here? D is 12.5 mm. I am converting it into meters, and then D square. This is CVT by D square, but this T should be converted into days. So 10 minutes, first minutes should be converted into number of hours, so divided by 60, then days means another 24. So this is what from this equation. Okay, what is the unknown which is there in this? This is just CV. CV I can write that 0.1963 into 12.5 into 10 to the power of minus 3 whole square into 10 into 24 divided by 10 minutes, right? So this is what the CV, and I told you CV will be constant. You can find out CV from the laboratory test like this. Now this CV can be used for field tests also. Now coming to the field, this CV is always constant. Field, what is the H value? H value is 25 meter. And what is the D? There also, though it is dense sand below the clay layer and just sand above the clay layer, it is still sand above and below. That means the drainage can happen both ways. In that way, D will be H by 2, here 12.5 meters, right? Now we got the H, we got the D, and what is the percentage of the consolidation? They are asking about 25, right? So what is the time for this much percentage of the consolidation when H is 25 meter in the field? That is what the question. You have to find out T. So we know the U value. Why don't we find out TV? Pi by, it is still less than 60. Okay. So pi by 4, 25 by 100 square. Can somebody tell what is the value of TV for this? 0.049. Okay, so right, thank you. Now you got the TV. So another CV, let us say TF लिखते हैं इधर, TF and DF, HF, right? So TF, because this is TVF, CVT by DF square. So you don't know the TV value, right? But we have already calculated using the laboratory tests, and this CV will be same because CV is constant for a soil. It is not laboratory or something. Okay, now you can use this value here. Let us say this is some, yeah, CV anyway, CV. So TVF, we know this value. Okay, later I will substitute. I didn't calculate, by the way. So what is the DF here? 12.5 meter square. You now write 0.049 equal to CV into TF 12.5 square. Okay, now can somebody calculate and tell me what is the CV value? Minus 4. Okay, now substitute this and tell me what is TF. I am expecting the answer in another.
10,400.
Can you tell me again?
10,400.7.
10,400. Can someone of you another one? Your talk. See, I see. You just substitute whatever is there. What? No, I can't hear anyone. Now tell me.
The same answer, sir.
You are getting the same answer. What did we miss then? See, nobody told me whether it is 10 or 60. Actually, it is 60. This is 60, right? Because 60 minutes for an hour. Now tell me, what is the value of this and what is the value of TF? You just multiply with 6, that's it, into 6, I think. If you have calculated seeing this by taking 10, you just have to multiply 6, then tell me the new answer directly TF. If somebody can tell me what is the new answer of TF, actual answer of the TF, that will be better. Or else you divide by 6. 10,400.
1733, sir. 1733.
1733.
Yes, sir.
Okay. Yeah, you are anyway nearer. 10,400 somebody said, by let us divide 1733. But you should get the answer like whatever I have done before this class. 1736. I don't know the range of key. Okay. So, range can be 1732. I'm just guessing 321740. As this is very big calculation, people may get 33, 32, whatever. Maybe they are giving range of 10 coming to these big values. Okay, yeah. So that is the answer. This is in terms of what? Days, minutes, seconds. Can you tell me? Can someone of you tell me what is the what are the units of this answer?
Minutes.
Minutes? Why? Why minutes? See, we have converted. This is the T. C into T by D square equal to T. This is T, capital TV. And this is the D. TV D square by small t will be T. Now this T is in minutes, 10 minutes. What did I do? I converted by including these two terms, two numerical values in this. So if I am using 60 multiplied by 24, so what will it become if it is in minute? Minute is converted days. Okay. So answer is 1733 days. Right? So this is how you should calculate the problems related to the consolidation. So I hope everybody understood, and I'll be giving the again recorded lectures, by the way, so you can understand again. You can watch these videos again. So shall we close the session?
Yes, sir.
Okay then. Thank you everyone. Thank you.
Hello.
Yeah, tell me.
You call that the video I get,
What?
recorded video I also get.
Recorded video. Okay, we will tell them, actually the authority who is conducting, we will tell them to conduct. Okay? Okay, right. Any other doubt? So I am leaving the meeting.
Thank you, sir.
Right, thank you.